Hello, this is George Blake, W6BDD, reporting again about the ATU-1000. I'm going to do a short video just to talk about some of the circuitry. And thank you for the comments. I appreciate them, and hopefully I answered your questions. There seems to be some miscommunication or misunderstanding about the operation of the relays. So I've seen at least one comment talk about relay K2 being energized and whether it was going into bypass or not. So let's talk about that a little bit. So K2, understandably, because it's between the two sets of banks of relays, is energized at the beginning. And understandably, you probably think that's a bypass relay. That is not the bypass relay. Okay. The bypass occurs through the set of 14 relays. So I will explain this a little further. K2 is to switch in your capacitors either ahead of the coils or behind the coils. So the way the circuitry works is it's called an LC network. Now, when the capacitors are behind the coil, it's more of an LC network. When the capacitors are ahead of the coils, it becomes more of a CL network. And it doesn't sound like there's much of a difference, but there is. It's the way that the impedance and the reactance occurs. So let's talk about this a little bit. So, and you really should, if you're a ham radio operator, understand how schematics look and how they operate. And then you can look at this and you can see for yourself how this operates. So the bank of coils, as you see on top, are in what is known as the normally open position. Now, whoever decided to draw the schematic, I think, drew it wrong. I've been a draftsman and a PC designer and engineer for a long time. And I would not draw the relays this way. The relays, as they're schematically shown here, are in the normally closed position, or not in the normally closed, the energized position. So what happens? The coils energize and pull the arms of the relay towards the magnet. That does not repel them. So this is actually shown in the energized position. But in actuality, they are in the de-energized position. So the de-energized relays, if you follow the circuitry from where the signal comes in, goes through the SWR bridge and goes up, and it first goes to L1, one side of it. The other side of it goes up to the relay, and it goes to what would be the normally open position, or normally closed position. So in the de-energized position, the signal is actually shorting across the coil. So the signal comes in, it goes to the coil, but because the relay is shorting across the coil is not in the circuit. And then as you follow across, each successive relay is also shorting across the coils. So in essence, this is the bypass position. So when it's de-energized, all of the coil relays are shorting out the coils. So it makes a direct path across them. The signal then goes to K2. This is the one that's in question. So K2 is not bypassing the signals. K2 is switching between the input to the coils and the output of the coils. The relays for the capacitors, the other set of 7 relays, are in the normally open position, and it keeps the capacitors out of the circuit. So this is also the bypass position. So as long as the 14 relays, besides K2, are de-energized, it is in the bypass position. And this is the position that the board goes into when you first power it up. The only thing that turns on is K2. Now, why K2 is turned on, I could only venture a guess. Maybe they're going to pick the coil relays with the capacitors after the coils first, before it switches to ahead of the coils. I don't know, I don't fully understand the matrix yet, or the sense of which coils and capacitors get picked. But K2 is definitely not, repeat, not a bypass relay. So it's only switching the capacitor banks in ahead or behind the coil. And then the output of the 2 sets of coils goes out to the output. So when the relays are in bypass, or when they're normally de-energized, it is bypassing the RF. And this makes sense because if you have your transmitter on and you first power up the antenna tuner, until you get it tuned up properly and you happen to hit transmit, the power is going to bypass the network and go through and out to the antenna or dummy load or whatever you're using. So a little better sense of this is I drew this out on paper. So here you see there's the input, and you see it split and go through the relay in the bypass position and out. So the coil is out of the circuit, basically. It's shorted. The other leg goes to this point. And this then gets tied to the capacitor relays, except that the capacitor relays are in the open position. When K2 is energized, as it is when you power up, all it's doing is placing the capacitors in the output. But again, because this bank of relays is open, it doesn't see the capacitance. So this is the bypass circuit. Okay. There's one more picture I have. Let me bring it up. This is a diagram that was drawn by another ham radio operator on Facebook to also explain this better. So as you can see, it says these are normally open relays. So that's not really true. These are normally closed relays. These are normally open relays. So this should be NC and this should be NO. And this is where K2 is. So all K2 is doing is picking the capacitors to either be ahead of the coils or behind the coils. Again, the bypass is performed by the 7 coil relays and the 7 capacitor relays being in a de-energized state. And in this way, it successively goes around each of these coils and out. And at the same time, there's no capacitance. So the only thing that's affecting the circuit may be any internal inductance or any internal capacitance, but it'd be very, very small, or what we consider parasitic. So that's my video for now. And hope you enjoyed it. Hope that was informative. And again, leave comments. And I will be posting another video showing the progress I've made on mounting my board set and my switches into a box. Have fun, 73s.